The 5 levels of readable code. I don't know about you, but I strive for readability. I do care about performance, but readability is crucial. Because if I can't read my code, how am I expected to understand it? But it's also true that readability is very subjective. What might seem elegant to me might look complicated to you. But we can always find a middle ground. That's why these articles exist, helping people out. Let's see what he suggests. Recently, I've been thinking a lot about code readability. What does it mean for a piece of code to be readable? Is it possible to define readability objectively? Should we attempt to do it? I say yes. Let us try. These are some of the questions I've been thinking about. And in this post, I present my answers in an attempt to start a conversation around readability. You're not the first one. There's a lot of people in the industry that give a lot of fucks about this, but I commend the effort. Here's the TLDR version. We're gonna skip that. I'm gonna read the whole thing. The importance of a code readability definition. A definition? I'm curious. Readability will always be somewhat subjective. And to some degree, that subjectivity is harmless. However, it can cause problems in some scenarios. If we're working with a team, it's important to come up with at least some objective guidelines regarding code readability. And that's because of code reviews. If the team can't agree on what constitutes readable code, then code review feedback will feel like arbitrary whims. That is true. When you're working on a team, you gotta take into account the expertise of your team members. If you were to write really smart code, but your team members don't happen to be as smart as you, they're not gonna have a good time. In short, teams need conventions. A team should have a vision when it comes to what constitutes good, readable code. And I completely agree with that. And to make things easier, smart developers should just stick together. A framework for thinking about code readability. Levels. Not long ago, I started thinking about code readability in terms of levels. This is a first. The levels represent specific concerns regarding readability, and they're ordered in terms of priority. So level 1 represents the most basic stuff you got to take care of first. For progressing towards higher levels, tidy up the basics, then go for the advanced stuff. Oh. Something like Maslow's hierarchy of needs, but for code. There will be some code examples, and I'll be using C# for those. However, what I'll show here applies to any language, unless I explicitly say otherwise. Without further ado, here are the 5 levels of readable code. Level 1. Your code does the bare minimum. Yes, level 1. Please spare me that programmers start counting at 0 nonsense. Actually, we always start counting from 1. You go first, then second, then third. But this nonsense about starting from 0 comes from pointers and offsets from addresses. You want to get the first element of an array in C, you access a pointer, and through that pointer, you specify an offset. The first element is at offset 0. So we don't start counting from 0, we start counting from 1. Just so happens that the first element is at offset 0. Level 1 of readable code refers to code that does the bare minimum. Think of simple readability guidelines such as picking descriptive names for variables, functions, classes, and so on. Well, even that one, I would say, can get quite complex. Because what constitutes readability or a readable variable name? What is a good variable name? It's very difficult. There was another article about that. Avoid too many indentation levels. Personally, I'm not very afraid of spaces or tabs. I do try to keep the indentation level low. I'm not pushy. Keeping cyclomatic complexity low. Avoiding comments that don't bring any value. That's a good one. Because you're usually taught to write a lot of comments, but without a lot of experience, your comments are gonna be very verbose and mostly redundant. The thing that I notice from people that are starting out is that they write comments that describe what the code is doing. But you can already tell what the code is doing by reading the code. Do you not know how to read code? What instead you could do is describe the logic, describe the intentions behind the code that you had to write. That is a lot more useful. Just keep the comments up to date. Keeping functions and other blocks of code small, yes, because human brain big, but big functions don't fit too well in big brain. Small better. Avoiding magic numbers. What if you're a wizard though? It's not hard to learn these kinds of best practices. You can pick up most of these through shared experience by listening to the feedback of more experienced engineers during code reviews, or by reading books and even blog posts like the ones listed above. Level 2. Your code is idiomatic. Consider the following C# class. So we've got a class who's a person. Person has name and an age. There's a constructor. You specify name and age. You can change the name, change age, and you can get age and get the name. Okay, there's nothing wrong with the above class. I'm not gonna get into that. At least not technically. The compiler happily compiles it, and the class works as it should. However, if you're at least somewhat experienced with C#, you notice something weird when you saw the code, the getter and the setter methods. The C# development team made the concept of getters and setters the first citizen class of the language early on, via the concept of properties. If there's no additional logic involved in the setting and getting of values, the programmer can make usage of auto-implemented properties. With a concise result, even the backing private fields no longer need to be explicitly declared. That is idiomatic. The point of being idiomatic is that you should write code that looks natural. Technically looks. You technically look at the code. You don't hear the code. I was gonna say sounds idiomatic. You would write this in Java, but not in C#, because you can do better. That's the reason why. All of this is to say that to be readable, a given piece of code needs to be idiomatic to the language it's written into. If you're writing C#, follow the coding conventions or coding standards of the language. The same applies to Java, JavaScript, and any other language. I think this is some really good advice. The Python community has a wonderful concept to describe Python code that adheres to the standards and philosophies of the language. Pythonic. A piece of Python code might work, but it's not Pythonic. And experienced Python engineers will find the code awkward to work with. A good analogy would be foreigners attempting to speak English, but by translating word to word what they would say in the native language. It sounds super awkward. Sometimes even confusing, but also funny. Why does writing idiomatic code matter for readability? When you look at code in whatever language, that doesn't look like what it should look according to the mental model you have of that language. It becomes harder to follow the code. Non-idiomatic code increases the cognitive complexity of a code base. It makes it harder to onboard developers who are familiar with the language standards and idioms. If you have an open source project, too many idiosyncrasies in the code might push away potential contributors. The more familiar something looks like to somebody, the less intimidated they feel about it. Of course, the opposite of all of this is true. Level 3. Your code reveals intent via tactical use of typing. As the title suggests, this item, unlike the previous two, only applies to statically typed languages, or perhaps dynamically typed ones that feature some kind of optional type annotation. Let's start with a simple example. Look at the following lines. There's only one. Disregard the magic number, which is itself already a problem. Consider that you know the drawLine method has a single parameter. Length. The line could have been made slightly more readable through the usage of named arguments. But even that wouldn't solve the biggest issue. What the heck is the unit of measurement? Besides harming readability, this problem opens up the possibility of bugs due to a mismatch of units. A portion of the code thinks the unit is in centimeters, while others might believe it's inches. And this has killed people. What am I advocating instead? Well, use typing to your favor. Here, a good solution would be to create a value object called, let's say, length. This type would have several static factory methods named after specific units of measurement, and its constructor would be private. Then you'd be able to rewrite the previous example to something like this. Length from centimeters. Reads nicely. Another example would be the usage of time span type to express durations instead of using primitive values, or implying the URI class instead of just strings or URLs, links. Maybe you're thinking all of this is simply a convoluted way of saying avoid primitive obsession. There's more to it than that though. To illustrate my point, I'll share another, maybe a bit contrived, I admit, example. Let's say you're solving a problem that calls for the usage of a stack. In this case, nothing is stopping you from using the list class as a stack, right? True. The add method would be your replacement for the push functionality. For the pop functionality, you use a combination of getting the last element from the list via its indexer and then using the remove add method to delete the item. The above solution, despite being somewhat convoluted, would work. But I'd
vehemently, vehemently,
vehemently,
vehemently, vehemently,
vehemently,
vehemently,
vehemently,
vehemently,
vehemently, vehemently, vehemently. I learned something. But I'd vehemently encourage you to just go and use the regular stack class. Using the more specific type would make the code immediately more readable to anyone who knows what a stack is. It would also make the code reveal its intent. Not just that, it would also be less convoluted, because you wouldn't need to do all of this process just to pop an element. You just have a simple method for popping an element. In short, unless you have a justifiable reason to not do so, I always prefer the type that more closely represents the concept or functionality you need. It'll not only make your code more robust, but also more intention revealing. Level 4. Your code doesn't mix levels of abstraction. Your code shouldn't mix more than one level of abstraction. Code that lives in the business rules portion of your code base shouldn't mess with the code that lives in the IO concerns neighborhood. I have lost count of the number of times I've seen this happen in the code. And even when you talk to people and explain to them how much of a bad idea this is and how bad the code becomes, they keep doing it. Disgusting. This is why we can't have nice things. I truly believe that this is one of the biggest contributors or bugs. People just don't care. By mixing code from one layer with another, you're introducing complexity. And like I said before, big brain, but not big enough. Why is this a problem? See the following function. So calculate average temperature, and it takes a file path. Yep, that's quite stinky. I think I'm not even gonna read the block of code. Just look at the function. Calculate average temperature, and it takes a path to a file. Why the heck would it take a path to a file? Why not just take an array of all the elements, or an iterator, or an object that provides all of the values? Anything, an abstraction, some sort of thing to keep this function away from the file system, because it has nothing to do with the file system. It shouldn't know about a file system. If you were to test this in isolation, you couldn't test this without a file system. You need to create fake files, when it would have been so much easier to just pass an array to the function. Get the gist. Holy crap, it's big. Doing so many things. It's parsing, it's reading a file. Oh god. The function reads and parses a CSV file containing climatic readings. Lines that don't have the expected two values, date and temperature, are dismissed. Is it even parsing a CSV file taking into account that characters need to be escaped? Of course not. This kind of code never does. I've seen that in the wild so much. Then it sorts the readings, removes the highest and lowest values, and finally calculates and returns the average of the remaining values. This is all that it should have done. This is all that it should have done. This function mixes at least two abstraction levels. The domain logic level, the part that makes the calculation, the low level, reading and parsing the CSV file. You could even make the argument that there are three levels, since the low level could be split into two, the file system manipulation and parsing. This example function isn't the hardest thing in the world to read, but it's certainly harder than it has to be. It mixes domain logic with I/O, error handling, and even parsing. A better solution would be to have a method that gets a collection of climatic reading and calculates and returns the average. In other words, a better and more elegant solution would be to have a pure function. This new method, besides being more readable, would be more robust, less error-prone, and also deterministic. Predictable. Always returns the same results for the same input, making it intrinsically unit testable. Level 5. Your code speaks the language of the business. Interesting take. You've reached level 5 when you write code that speaks the language of the business. This sounds like something that the business people would love to hear. When you use terms that are the same ones that domain experts use. In other words, yeah, I'm pretty much advocating for the same thing that the pragmatic programmers call program closer to the domain. Or that Eric Evans famously dubbed ubiquitous language in his classical but definitely not page-turner tome domain-driven design, tackling complexity in the heart of software. You may have noticed that complexity plays a big role in creating shitty software. That's why most of this article is convincing you to take simpler approaches to avoid complexity. If your code uses unorthodox terms instead of industry terms, it makes onboarding harder when you bring in new people that are familiar with the business but new to the code base. If the code uses different jargon than that of stakeholders, communication becomes more taxing, since it requires you to perform a constant mapping between concepts just to stay afloat. Level 5 is somewhat of a logical consequence of level 4. If you carefully segregate the concerns of your app, making sure that high-level code doesn't mix with low-level code, the tendency is for the high-level code to become closer and closer to the domain in terms of naming. Yes. Level up the readability of your code. Most programmers would agree that code readability is vital, but what about agreeing on what readable code looks like? That's a horse of a different color. As I said earlier, I think a level of subjectivity when it comes to readability is both inevitable and harmless. However, in the context of a team, there has to be at least some consensus of what readable code is. Otherwise, code reviews become exercises of futility and team morale sinks. I believe that our industry would benefit from a more objective way to reason about readability. In this post, I gave my small contribution in the form of a readability checklist in prioritized order. Thank you. Thank you. But again, the idea of this post isn't to give a definite answer, but to start a conversation. Do you think the levels models make no sense? Or maybe you'd like to share your own levels. I invite you to share your opinion via a comment or shoot me an email. Let me give you the link. Yeah, put the link in chat. So, discuss away. What bugs me the most about this is the level 4 example where the author throws invalid operation exception, which is completely wrong for the purpose he wants to throw an exception, and he swallows the base exception. The unnecessary list allocation at the end is also great. Oh, Reddit. The author should write C# examples of better quality, otherwise people question intended message. I too read through articles posted here so I can nitpick the actual code while disregarding the topic at hand. Yes, yes.